Video, you will be learning how to solve the circuit in using Thevenin's theorem when you have multiple sources. So if you see in this circuit, we have 20-volt source, we have 2 ampere source, and we have 15-volt source. So we have to redraw the circuit and draw its Thevenin's equivalent circuit. So we have to do Thevenin's equivalent with multiple sources. So when you have multiple sources, for the same thing, first we have to do VThevenin and RThevenin. So I will start with RThevenin first. So when we are finding for the RThevenin, we will redraw the circuit. The rule is all the voltage sources are considered short and all the current sources are considered open. So voltage source short and current sources open. And RL load. Load. So whenever you are finding RThevenin, this is what you need to follow for every circuit. So I'm redrawing the circuit for RThevenin. Following the rules that I have written, this voltage source is short. This voltage is short here. This current source is open, so there is no current source here. And then this voltage source is short here. And then this load resistance RL is removed from here. So following these rules, I have redrawn the circuit for finding RThevenin. So this represent R1, R2, R4, and R3. So point A and B are the points where you are finding RThevenin. So you remove the load and the point from where you remove the load, at that point you are finding RThevenin. So you will start from here and go towards RThevenin to find it. So first of all, R1 and R2, they are in series. So my R1, R2 will be R1 plus R2. That gives me 2 plus 3, 5 ohm. And you redraw the circuit. Now you can see easily that R1, 2, and R4, they are in parallel. So R1, 2, 4 combination will be R1, 2 parallel to R4. So R1, 2, we found 5, R4 is 1, and this is 4 ohm. So that means 5 times 1 divided by 5 plus 1. That gives me 5 divided by 6. So just doing the math here, 5 divided by 6 gives me 0.83. Now I will redraw the circuit again. So R1, 2, 4, and then we have R3 here. And this represent A point and this represent B point. So RThevenin is now the resistance across A and B. So now these two resistors, they are in series. So I can say that RThevenin is R3 plus R1, 2, 4. So R3 is 4 and R124 is 0.83. So we calculated RThevenin as 4.83 ohms. So this is the steps to calculate RThevenin. Now, the next step is how to calculate the VThevenin. Since there are multiple sources, right? So we will consider one source at one time to solve it. So I'm just redrawing this circuit here on my page 2. Circuit on page 2 here. resistance 3 ohm, resistance 1 ohm, resistance 4 ohm, and then we have another source, and then we have RL. This is R1, this is R2, this is R3, and this is R4. I have redrawn the circuit from the previous page. Now, since there are three different sources, source 1, source 2, and source 3, I have to consider one source at one time. So I'm using superposition method to solve for this circuit. So considering 20 ohm source, 20 volt source, sorry. So you consider one source at one time. So as per the superposition method, if I'm considering this source, all other voltage sources will be considered short and all other current sources will be considered open, and redraw the circuit. So this is 20 volt plus minus, it should be given here plus minus, and this arrow was for 2 ampere current source. Let me just check the arrow, it was upward. Okay, so you have redrawn this circuit. So this represents R1, R2, R4, and R3. And the point here where A and B, where RL was connected, so RL is connected across A and B point. This is considered open, and the voltage across these 2 points represent Thevenin. So when I'm saying I'm considering one source at one time, so you're considering 20 volt source, this source is open, so there is no current source, and this source is short, so there's like this, right? So you have redrawn the circuit considering these sources, only one source at one time. Since this is open, current here is 0. So this current is 0, voltage here is 0. So that means I can do here just ignore this resistance, just to simplify. Why I'm ignoring it? Because current is 0. Now, due to 20 volt, this current goes here, this current goes here, then current goes here, then current goes here. So the current remains same. R1, R2, R4 have same current because current in R3 is 0 here, right? So current in R3 is 0. So that's why the whole current circulate in this path. So R1, R2, R4 are in series. Why? Because the current through R1, R2, R4 is same. So the current I will be 20 volt divided by total resistance R1, R2, R4 in series. So 20 volt divided by 2 plus 3 plus 1. So this gives me 20 divided by 6. So let's do the math. So 20 divided by 6 give me 3.3 ampere. So 3.3 ampere is the current. So now you know the current flowing through R4 is 3.3 ampere. So voltage across R4 will be Thevenin. So that is voltage across R4. So that is current flowing through R4 times R4. So current is 3.33 and R4 is 1 ohm. So that gives me 3.33 volt as Thevenin. Now the next step is to figure out the polarity. What will be the polarity of the voltage across point A and B? See the direction of current. The direction of current in R4 is going this way. So it goes from positive towards negative. That means point A is positive because this is point A and point B is negative. So this is the polarity. So we have solved the circuit using one circuit at one time. Now we will consider the second circuit. So I'm considering 2 ampere source. So consider 2 ampere source. So when you consider 2 ampere source, this voltage source 20 volt is short. 2 ampere source current, and this goes this way. This is the resistor 3 ohm. This is the resistor 1 ohm. And this is resistor 4 ohm. And this voltage source is short like this. So this is the point. So the voltage across point A and B represent Thevenin. Now, if you see this one here, this is R1, R2, R4, and R3. Since R3 is in the open circuit, current flowing through R3 is 0. So there is 0 current here, 0 amp. So voltage here is 0. So I can simply ignore this. So I'm just ignoring this just for simplicity because current is 0. Now we are just, this will represent point A and this will represent point B. Now if you see this 2 ampere current is divided here and then going this way. So that's what this is I1 and this is I2, right? So 2 ampere current is split into I1 and I2. So now you can see that R1 is in parallel to R2 and R4 resistor. So basically, if I redraw, this is 2 ampere, this is R1, and this one is R2, R4 combined because this is in series because I2 current flows through R2 and I2 current flows through R4. So R2 and R4 are in series. So the current divider rule, this is I2 and this is I1. I need to find out voltage across point A and B. That means voltage across R4. So Thevenin is voltage across R4. That means current flowing through R4 times this. So I2 times R4. So I need to find out I2 from here. So using current divider rule, I2 will be I total, that is 2 ampere, that represent I total, multiplied with R1 divided by R1 plus R2, R4. So just make sure you note this thing that in this branch, there is 3 ohm resistor and 1 ohm resistor. These two are in series, so that forms R2, 4. So here you need to consider both together because it's considered as one single branch. And now let's go back here. So solve for this. IT is 2, R1 is 2, and R1 is 2, R2, R4 is how much? That is 3 plus 1, 4. That gives me 4 divided by 6. So you do the math. Divided by 6 gives me 0.66 ampere. That is the current that flows through this branch. Now, what will be the voltage across AB? So Thevenin will be current I2 times R4 because here the Thevenin is the voltage across this branch. So the current that flows through here and times the resistance, right? So let's go here. So current I2 is 0.66 times resistance 1. So that gives me 0.66 volt. Now the next step is to find the polarity. You see the direction of current. Current is going this way. So that means it's going from positive towards negative. So A is positive, B is negative. So we have solved for two sources. Now we are left with the third source. So there are three sources, so we have to consider three different cases. Now is the third source, that is this voltage source. So the voltage value given for this source in page, let's go to page 1, it was 15 volt. So this is 15 volt here. So for this we have to solve. I'm just adding the page and then I will be redrawing the circuit. So this is 20 volt. This is 2 ampere. This is then another resistor. I'm just redrawing the original circuit and then I will be explaining the current due to the voltage due to this 15 volt source. We have already considered the sources. We have considered 20 volt, we have considered 2 ampere source. Now we will be considering 15 volt source and redraw the circuit. So consider 15 volt source and redraw the circuit. All the voltage sources are always considered short and all the current sources are considered open, and you redraw the circuit. Now, the only voltage source in this circuit is, this is R1, R2, and R4. Only voltage source in this circuit is 15 volt. So due to this 15 volt, the current that flows through R3, there should be current, but since this is open, so zero current flows here. Zero current flows there, so there will be no current flowing through this whole circuit because the power source is connected to the open circuit. There is no closed path, so there will be no current flowing. So basically, this will be considered as this point, A and B point. So you have 15 volt source and it's connected between A and B. So that means basically you are measuring across this source. So this represent A point and this represent B point. So this is like B is here, B is here. So same thing. So you're measuring across. If you put a meter across this, so what voltage you will measure? You will measure the same voltage as the source voltage. So from here, V Thevenin is 15 volt. Now what will be the polarity? For A, this is negative. So A is negative and for B, it is positive. So now we can see that we have solved this circuit here for all three different sources. We consider 20 volt, we consider 2 ampere, and we consider 15 volt. So this is superposition method. Now you will recombine the VThevenin due to all three sources. So due to all three sources, what will be your net? So due to all three sources, VThevenin due to all three sources. So you will see the polarity at point A. So let me go back to page 2 here. So polarity for point A here is positive, and that time the voltage was 3.3. So I will write here 3.3 as positive. Then I will go back to page 2 to see here. Polarity for this voltage is again positive here, and the voltage here is 6.66. So I will put here plus 0.66. Now this point here, polarity for A is negative. So for this, polarity for A was positive, polarity for A was positive, but in this case here, polarity for A is negative. So I will put here negative 15. Now solve for this. So how much is that? That is considered as 3.3 plus 0.33 plus 0.66 minus 15. That gives me minus 11.01. That is your voltage, Thevenin voltage. This negative sign represents just the polarity, but the magnitude of voltage is 11.01. So when you redraw this circuit for Thevenin, it will be V Thevenin, then R Thevenin, then R load. So where VThevenin represent minus 11, that means the polarity will be opposite. So if you want to, you can put here minus 11 or minus 11.01, or you redraw this as opposite polarity like this. So this represent R Thevenin, this represent RL, and this is your 11.01. So this is how you draw for equivalent circuit for Thevenin. Thank you.